Hello friends, welcome to one more edition of this effort of mine for the computer-based platform Edumate Plus. Edumate Plus is a computer-based testing platform for JEE, NEET and MSTCAT. And an initiative from that was, I was trying to declutter chemistry for you. And today we are trying to declutter this chapter, some questions in this chapter, coordination compounds. Very important chapter as far as any entrance exam is concerned, because at least about 3 to 4 questions are when asked from this chapter. So 3 to 4 questions in say NEET 45 is about nearly 9 to 10% weightage is from this chapter. Very, very important. It's clear? So without wasting much time, we begin with the first point that we have to answer. The highest coordination number in a coordination complex. See, if you look at any this NCERT books, state textbooks, the highest coordination number they say that the highest coordination number is 8. This 8 is for this complex. One of the examples which they give is MOCN8 minus 4 anion. So this is generally what is purported. But you have to be very careful, especially with JEE mains. We have to look at the distractors properly. Because if 12 is given instead of 8, if highest is 8, then 8 is the answer. Then they are going as per the NCERT book. But remember one thing, actually, so this is, when you look at the distractors, and if the answer is 12, then the correct answer is 12. Why? Because, so actually, hexanitrato, that means nitrate is the ligand, NO2 minus. Hexanitrato, serate 3. Sorry, serate, it will be an anion. So hexacinoserate 3 anion has a coordination number equal to 12. So you will say, sir, there are only 6 ligands. Here nitrate is acting as bidentate ligand. It is acting as bidentate ligand, and that is why we have 12 coordination number. 6 the ligands, but the coordination number is 12 because nitrate is acting as a bidentate ligand. So this was one observation. So I again repeat, you have to be very careful. If one of the distractors is 12, then 12 would be a more appropriate answer in JEE, because such a stable compound does exist, even though our textbook says 8 is the highest coordination number. So in our decluttering of chemistry for the chapter coordination compounds, we take one more question. See which point a positive ion is avoided to combine with a complex anion. See, we are all very, familiar with lithium aluminium hydride, LiAlH4. So lithium aluminium hydride, here lithium was the cation. So if I split it, the simple cation was lithium and the complex anion was aluminium hydride, AlH4 minus. One very rare example of lithium complex. So answer to my question is, which positive ion is avoided to combine with complex ion? Even though one exists, lithium aluminium hydride, lithium plus is avoided. Why is it avoided? Because of its high polarizing power. Because of its high polarizing power, because of its high polarizing power, the anion high polarizing power towards the anion. Towards anion, it abstracts. It abstracts means it removes. It removes fluoride, okay, or an oxide ion. So whenever your anion has a fluoride or oxide ion, it becomes unstable, and that will be abstracted out by lithium to form lithium fluoride, lithium oxide, or so on. This survived because it did not form lithium hydride. Because it's hydride, it survived. Otherwise, the oxide and the fluoride, it will not survive. So generally, lithium as a cation is avoided when forming a complex with a complex anion. So this was one more observation in our interval. We have the next question, that is orthometaparatoluene shows what kind of isomerism. So if I look at toluene, ortho meta para. Molecular formula same, but there is an isomerism in the ligand. So here what is happening, so there is an isomerism in the ligand. So therefore it will show ligand isomerism. So this will be a question combining amines, a chapter of nitrogen compounds, and what you call coordination compounds. So you should know what is toluene. That's one first problem that we have. What is toluene? And then orthometa-para, they are having isomers, and therefore they show ligand isomerism. We have a very interesting, commonly asked question. See, when we do Brown ring test, the question is, what is the reason for the Brown ring test? See, what happens is, when you look at this compound, a colorless compound, FeH2O5NO, here what happens is, Fe is +2, NO is 0. Is this clear? So in this state, so NO is nitrosyl. Okay, so you have penta-aquo-nitrosyl iron 2. Iron 2. Is this clear? So what happens over here is that this will be colorless. Now what happens is, this is what we call a reaction called as charge transfer mechanism. So this charge transfer mechanism, we all know that nitric oxide has an unpaired electron. So what is going to do? That unpaired electron, it transfers to Fe, and Fe becomes Fe plus 1. Okay, Fe becomes plus 1, H2O5, and this is nitrosonium now. So from nitrosyl it has become nitrosonium. If this is colored, because of this electron transfer, energy is absorbed, and that gives a brown color to the complex. So coming back to our question, if it is a complex with brown color, then Fe will have a charge of Fe plus 1. If it is colorless, then Fe will have a charge of Fe plus 2. We might combine this with the fifth question in our thing. The oxidation state of Fe Same concept, oxidation state of Fe in sodium nitroprusside. See, what happens is sodium nitroprusside Na2 Fe CN5NO. So here what happens is Fe is plus 3 and your NO is 0. Okay, so this, now what happens is because of charge transfer mechanism, this is colorless. So because of charge transfer mechanism, what is happening? The NO, nitric oxide, loses its electron and will become NO plus. So we have this compound Na2 Fe plus 2 CN5, and this becomes from nitrosyl to nitrosonium ion. Are you understanding? And this will be red in color. Because there has been a charge transfer from NO, which has now become NO plus and Fe plus 2. Like that, you have got many more examples which you can check up. I've just given you a hint where you start with. And since these are questions which are asked, I have taken them from the portal, computer-based testing portal, Edumate Plus, to discuss it. I'll come back with another 5 interesting questions in our next episode. Till then, goodbye.